My last video explained the formal definition of a cause. This video discusses how we talk about causality in research, whether we think a study did a good job of demonstrating that one thing caused another or not. This is called the internal validity of a study. This video defines internal validity and discusses three main threats to it: measurement error, omitted variable bias, and reverse causality. As a reminder, causality means that we see a relationship between two variables where they are correlated. When one variable changes, the other changes. The cause comes before the effect, and no third variable can explain their relationship. We say that a study is internally valid when it does a good job at showing that a correlation we observe is actually a causal relationship. But there are a lot of ways this can go wrong. These are called threats to the internal validity of a study, and there are many. In this video, I will discuss three important ones. The first and most important part of doing good research is making sure you are studying what you say you are studying. Whether we are doing qualitative or quantitative research, we make assumptions and simplifications when we move from discussing a broad concept, like a leader's legitimacy, to deciding how we measure this. Whether we use a qualitative measure, like the way a leader is portrayed visually on television, or a quantitative measure, like a poll about a leader's popularity, when we move from defining an idea to finding ways to observe it, we lose part of that idea. Citizens may see a leader as legitimately elected, even if they don't like the leader, for example. As discussed in my video on operationalization, if you choose a measurement that consistently over- or underestimates your concept, you have introduced bias into your study. This concept is called construct validity, and when you do it poorly, you have measurement bias or error. Because you can't say you have found that one thing causes another if you never measured those things correctly in the first place. The second threat to internal validity relates to the second requirement for causality, that the cause comes before the effect. When you can't demonstrate this, you may have reverse causality. Your effect might actually be a cause. For example, the United States holds elections in what are called single-member districts. We elect representatives from a geographic area, and whoever gets the most votes wins. The US also has a two-party system, which is the most likely outcome of this type of electoral system. But it's actually not clear whether the institution causes the number of parties, or whether those parties choose the institution most likely to keep them in power. Here's what I mean by that. A common theory is that the magnitude of the electoral system determines the numbers of parties. This is called Duverger's law. When districts elect one person, you get two parties. When you have larger districts, Germany, for example, elects between 10 and 50 or so representatives from party lists in what are their equivalent of states. In those cases, you get more parties. It doesn't actually always work like this. The UK has the same electoral system as the United States, but in recent years we have seen many parties emerge there. So it's not clear that the institution is the causal factor in this case. The fact that the US has had two parties for such a long time might actually be the reason why we keep our single-member majoritarian system, not the other way around. That is called reverse causality, and it's why we have to show that a cause comes before an effect. The final threat to the internal validity that I'm going to talk about here is omitted variable bias. The third and most important part of demonstrating causality is ruling out alternate explanations. So when you don't do that, you have omitted, or left out, a control variable. Let's go back to the US two-party system. If we want to prove that this is a result of our electoral system, then we don't just have to show that the institution came first, but we also need to show that nothing else explains our number of parties better. Another common theory of what determines the number of parties has to do with social cleavages. When a country's population can be divided into many different categories, like race or ethnicity, social class, religion, etc., when this happens, you are likely to get many parties to represent all of those categories. You might get parties based on social class, like a Social Democratic Party or a Labor Party representing the working class. Or you could get parties based on religion, such as India's largest party, the BJP, which advocates for Hindu nationalism. When a country's population is polarized into two groups, as the United States is right now, it tends to be represented by the two parties those two groups fall into. So to show that the electoral system is a cause, you need to rule out polarization as a cause of the two-party system in the US. That's ruling out alternate explanations. Along with measurement bias, omitted variable bias is one of the most common ways to critique someone's research. You can say that they didn't take all the factors, or control variables, that they needed to into consideration. These last two threats to internal validity, reverse causality and omitted variable bias, often get lumped into what is my least favorite word in political science, endogeneity. I am not going to hold you responsible for this word, but I am going to discuss it for a minute so that you don't worry if you see it in an article. I hate this word because it refers to two different ideas. Omitted variable bias, also known as you didn't rule out alternate explanations, and reverse causality, aka your effect is actually your cause. You will see this word used as a noun and as an adjective, endogenous, and it is the opposite of exogenous. Exogenous is good. If something is exogenous to an effect, it means it's an independent variable. It can be a cause. Saying that you have an endogeneity problem or something is endogenous to a variable is bad. It means that you don't have a causal relationship. Again, I will never ask you to use this word, but I mention them because academic language is opaque, and this is one of the most difficult to understand parts.